Okay, let's continue. We'll study inequalities. Or this is section 2 of chapter 3. So I'll write section 2, inequalities. So let's begin. We can ask, do we have an order on real numbers? So definition, we do have an order. Let A, B be reals. We say A is less than B if A is to the left of B. Right? So we say A is less than B. Saying A less than B means the same thing as A is to the left of B. Okay. So so we can compare any two real numbers. Okay. And we have another notion, so a specific notion called positivity. Let A be a real. We say A is positive if A is to the right of 0, that is A is greater than 0. Saying A is to the right of 0 or 0 is to the left of A mean the same things. So first we defined what A less than B means. A less than B means A is to the left of B. A is positive means, and secondly we defined positivity. Saying A is positive just means A is greater than 0. So these are some basic definitions. Now we can ask, let A, B be reals. Can we rewrite the statement A less than B in terms of positivity? So we have the following observation. This is just A less than B in terms of positivity. Let A, B be reals. Then saying A less than B is same as saying the number B minus A is positive. So we'll prove this. We'll first prove that A less than B implies B minus A is positive. So say A is less than B. It means, hence, A is to the left of B. Left of B. So A is less than B. So A is to the left of B. But note that A plus box equals B for box equals B minus A. Okay. Now, since A is to the left of B, this box is positive. Hence, so A plus box is equal to B. This box is positive. I'll write another picture. So A, B. So A plus box is equal to B, and A, since A is to the left of B, this box is positive. Hence, the box which is B minus A is positive. So we begin with A is to the left of B and proved that B minus A is positive. Now we'll show the other direction. Say B minus A is positive. Note that A plus box equals B for box equals B minus A. And note that we have the above box is positive. Hence, so if you add plus box to A, you get to B, and the above box is positive. Hence, A is to the left of B. So we started with B minus A is positive. Hence in the relation A plus box equals B, the box is positive. Hence A is to the left of B. So we showed that we began with B minus A is positive and showed that A is to the left of B. Sorry, this is B. A is to the left of B. Or I'll write A is to the left of A plus box equals B. So we begin with B minus A is positive and showed that A is to the left of B. Here we began with A is to the left of B and showed that B minus A is positive. Right. So we have this equivalence. Whenever we say A is to the left of B, we can rewrite it as a positivity statement. A less than B is same as saying A less than B is same as saying B minus A is positive. So hence, in a way, to study inequalities, it suffices to study positivity. To study positivity, we can rewrite any inequality A less than B in terms of a positivity statement. B minus A is positive. So in a way, to study inequalities, it suffices to study positivity. Okay, here's an example, by the way. So for example, 2 is less than 3 because 3 minus 2 equals 1 is positive. So this is one example of using this property. Okay, in a way it suffices to study positivity. Now we can ask, what are the basic properties of positivity? So more specific, to ask a more specific question, we can ask, how does addition, multiplication interact with the notion of positivity? So here we'll use one observation. Note that some product of positive rationals is positive. So we know that the sum and product of positive rationals is positive. So it is clear. This suggests, so we will not prove it. So observation, sum and product of positive rationals is positive. So we can assume that sum and product of arbitrary reals is also positive. Positive reals is positive. So sum and product of positive rationals is positive. We can guess sum and product of positive reals is positive. So sum and product preserve positivity. Let A be positive reals. Then A plus B, AB are positive reals. So sum and product of positive reals is positive. So this is one basic observation. Sum and product preserve positivity. If A and B are positive reals, then A plus B, AB are positive reals. This agrees with our already, so with our intuition. We already know that sum and product of positive rationals is positive. So this agrees with the corresponding statement for rationals. Sum and product of positive rationals is positive. We extend the statement to saying that sum and product of positive reals must be positive. So this is one observation will not prove it. So sum and product of positive reals is positive. So now we can again ask, we are looking for properties of positivity, right? So we can ask another question. Can we do casework using positivity? This is a vague question. Can we do casework using positivity? So this is an observation. Let A be a real. Then either A is to the left of 0, let's begin with to the right of 0, or A is equal to 0, or A is to the left of 0. Hence, so if A is any real, then A is, so if this is a number line, A is either here or here or here. A is either to the right of 0 or is equal to 0, or A is to the left of 0. Hence we have this following observation. So this is called trichotomy. Let A be a real, then either A is to the right of 0, that is A is positive, or A is 0, or A is to the left of 0, that is minus A is positive. So we have another fundamental observation about positivity, namely, if A is a real number, then either A is positive or A is 0 or minus A is positive. So we have two observations. Addition and multiplication preserve positivity, and we have trichotomy. So if A is a real number, either A is positive or A is 0 or minus A is positive. Exactly one of these hold. So now we have two basic observations. So note that the above two observations so what are the observations? Multiplication, so addition, multiplication preserve positivity. Another observation is trichotomy. If A is a real number, then either A is positive or A is 0 or A minus A is positive. The above two observations can be taken as can be taken as the basic properties. So these can be taken as the basic properties of positivity. We asked what are the basic properties of positivity. In a vague sense, the fact that addition and multiplication preserve positivity, and the fact that every real is either positive or zero or such that its minus a is positive. These two properties can be considered as the basic properties of positivity. So we have the basic properties of positivity, and we know how to rewrite any inequality a less than b in terms of positivity. A less than b can be rewritten as b minus a is positive. Now we can start to prove some properties about inequalities. Right. So now we can ask, can we take chains of inequalities? So we can ask with a more vague and more general question. What are the operations we can perform on inequalities? So how do we manipulate inequalities in a vague sense? What are the operations we can perform on inequalities? So we can ask a more specific question. Can we take chains of inequalities? So here's an observation. We can call it chains of inequalities, or we can also call it transitivity, or I'll not write transitivity. Shall I write transitivity? Yeah, it can also be called transitivity. So here's the property. We can take chains of inequalities. Let A, B, C be reals. Let A less than B and B is less than C. Then we know we have that A is less than C. So we can combine the two inequalities A less than B and A less than C and take the chain A less than B less than C to infer that A is less than C. So we can take chains of inequalities. A similar observation we did for when looking at modular arithmetic. A is congruent to B mod D and B is congruent to C mod D implies if A is congruent to B mod D and B is congruent to C mod D, then A is congruent to C mod D. Hence, we can take chains of congruences. So similarly, if A is less than B and B is less than C, then we can say A is less than C. Hence, we can take chains of inequalities. So here's the proof. So we know A is less than B and B is less than C. So note that B minus A and C minus B. So rewriting the inequalities, B minus A and C minus B are positive. Hence B minus A plus C minus B equals C minus A. So sum of positive numbers is positive. So hence this is positive. Hence, so B minus A plus C minus B is just C minus A is positive. Hence C minus A is positive. Hence we see that A is less than C. So this step we used because addition preserves positivity We know that b minus a plus c minus b is positive, hence just c minus a is positive, that is a is less than c. So we can take chains of inequalities. Can we take chains of inequalities? Yes. Now we can ask another question. So can we add a number, or can we add a number both sides of an inequality? Or I'll write a more specific way. Or shall I write? Okay, we can write it. Can we add a number? So we can take chains of inequalities. Can we add a number both sides of an inequality? Can we add a number both sides of an inequality? So let's see. So here's the observation. Addition of numbers to inequalities. So this is the basic observation. So we can add numbers to inequalities. Let a, b be reals and a is less than b. Let c be a real. Then you can add c both sides and it will preserve the inequality. Then a plus c is less than b plus c. We can add numbers to inequalities on both sides and the inequality won't change. So here's the proof. We know that, so note that b minus a is positive. Hence, and note that b plus c minus a plus c equals b minus a. So this quantity is positive. Hence, a plus c is less than b plus c. Note that b minus a is positive. Then note that b plus c minus a plus c. If you consider this quantity, this is also b minus a, which is positive. Hence, a plus c is less than b plus c. A less than b implies a plus c is less than b plus c. Can we add a number both sides of an inequality? Yes, we can add a number both sides of an inequality. Now we can ask another question. So can we multiply a number both sides of an inequality? So we can ask a more specific question. Can we multiply a positive number both sides of an inequality? Can we multiply a positive number both sides of an inequality? So it turns out yes. So here's the observation. So we can say multiplying positive numbers to inequalities. So here's the observation: let A, B be reals and A is less than B. Let C be a real and C is greater than 0. C is positive. Then AC is less than BC, right? So we can multiply both sides, or instead of always writing let A, B be reals, let C be real. That's already understood. Let A be less than B. Let C be greater than C be positive. Then AC is less than BC. So here's the proof. Note that B minus A and C are positive. Now multiplication preserves positivity. Hence C into B minus A is positive. Hence CB minus CA is positive. Hence CA is less than CB. So if we begin with A less than B and we consider a C greater than 0, then AC is less than BC. A less than B implies AC is less than BC as long as the C is greater than 0. Right, so multiplying positive numbers to inequalities. Can we multiply a positive number both sides of an inequality? So the answer is yes. Now we can ask, can we multiply a negative number both sides of an inequality? And right, so let's ask that question. Can we multiply a negative number both sides of an inequality? So here's the observation. So it turns out we can multiply a negative number both sides of an inequality, but we need to do a slight modification. So this we can say, this we said multiplying positive numbers to inequalities. This we can say multiplying negative numbers to inequalities. So note that in all these observations, questions and observations and proofs, we are reducing the statement to a positivity statement, and we are using the basic properties of positivity, right? So okay, multiplying negative numbers to inequalities. So let A be less than B, but now let C be less than 0. Then AC will turn out to be greater than BC. So if you begin with A less than B and multiply both sides by a negative number, then you will flip the inequality, so to speak. A less than B becomes AC is greater than BC. If you are multiplying by a positive number, then A less than B, after multiplying by a positive number C, the inequality will remain in the same direction. A less than B, then AC is also less than BC. But if we begin with A less than B and we multiply by a negative number C, then AC will become greater than BC. You start with A less than B, and after multiplying by a negative number, we get AC is greater than BC. So inequality flips. So multiplying negative numbers to inequalities, this is the rule. So here's the proof. Note that B minus A and minus C are positive. Hence, minus C into B minus A is positive. Hence, so AC minus BC, this quantity is positive. Hence AC is greater than BC. So we begin with A less than B, that is B minus A is positive, and we get that AC minus BC is positive, that is AC is greater than BC. So the inequality flips. Right. So we have asked so far, what questions did we ask? Can we add the number both sides of an inequality? Yes, we can add a number both sides of an inequality. So first we asked, can we take chains of inequalities? Yes, we can take chains of inequalities. Can we add a number both sides of an inequality? Yes, we can add any number both sides of an inequality. Can we multiply a positive number both sides of an inequality? Yes, we can multiply a positive number both sides of an inequality. The direction of the inequality will remain the same. Can we multiply a negative number both sides of an inequality? Yes, so to speak, we can multiply a negative number both sides of an inequality, but the inequality direction will flip. We begin with A less than B, then we'll get AC greater than BC. So can we multiply a negative number both sides of an inequality? So yes, we can multiply a negative number both sides of an inequality as long as we flip the direction of the inequality. So adding numbers, multiplying both, taking chains of inequalities, adding numbers both sides of an inequality, multiplying both sides of an inequality by a positive number, multiplying both sides of an inequality by a negative number. These are some basic observations we have made. So now, so here's, I think we can illustrate this, the last kind of observation, by an example. So example, note that, so we start with 1 is less than 3. Okay, now we can multiply both sides of an inequality by 2. Multiplying both sides by -2, we get -2 times 1 is greater than. So note that we have flipped the direction of the inequality. -2 times 3, that is -2 is greater than -6. Indeed, we can see that -2 will be somewhere to the right of -6. Hence -2 is greater than -6. So we began with 1 less than 3 and we multiplied -2 both sides. We got -2 is greater than -6. So we need to flip the inequality. From 1 less than 3, we flipped and changed it to -2 greater than -6. So after multiplying by -2 both sides, the inequality direction gets flipped in an informal sense, right? So this is one example. And now, so adding numbers to inequalities, multiplying both sides of an inequality by a positive number, multiplying both sides of an inequality by a negative number. Now we can ask another question. Can we add inequalities? If we have two inequalities, can we add them? So, right, so can we add inequalities? Here's an observation. Adding inequalities. So let A less than B and let C be less than D. Then we can add them, so to speak, and get A plus C is less than B plus C, B plus D. The sum of the left hand sides is less than the sum of the right hand sides. We can add A less than B and C less than D to get A plus C is less than B plus D. So in a sense, we can add inequalities. Here's the proof. Note that, so we are given A is less than B, that is B minus A is positive, C is less than D, that is D minus C is positive. So B minus A, D minus C is positive. Hence, B minus A plus D minus C, the sum of these positive quantities is positive. So hence, so we can group the B and D together and A and C together. B plus D minus A plus C is positive. Hence, A plus C is less than B plus D. So if we begin with A less than B and C less than D, we can conclude that A plus C is less than B plus D. right? So we can add inequalities. So we can ask another question: can we multiply inequalities? So note that we have reduced all the inequality properties, the proofs of all the basic inequality properties, to positivity statements, and it became very simple to deal with. Okay, so can we multiply inequalities? We can ask this question. It turns out we can, as long as all the terms involved are positive. So observation: multiplying inequalities. So let 0 less than a less than b and 0 less than c less than d. So all the terms involved are positive. Then we can actually conclude that, so 0 less than part is important. So all the terms involved are positive. Then we can multiply. Then we can say that AC is less than BD. So here's the proof. So we'll give, so one way to approach is, we have AC. So AC is less than, so A is less than B, hence AC is less than BC. This is because by multiplying A less than B by C, both sides. Both sides is understood. Multiplying A less than B by C, we get AC is less than BC by C greater than 0. C is greater than 0. So we can multiply both sides by C. Then further, then BC is less than DC. Sorry, not DC, BD. So this is by multiplying C less than D. C. So the C less than D inequality, multiplying C less than D by B greater than 0. So we got AC is less than BC by multiplying A less than B inequality by C greater than 0, and we get BC is less than CD by multiplying C less than D inequality by B greater than 0. Hence, AC is less than BD, right? So we showed that if we have 0 less than A less than B and 0 less than C less than D, then we can say 0 less than AC less than BD. We can multiply inequalities as long as all the terms involved are positive. So there's an alternate proof of this. This sounds a little bit like a clever proof, so we'll give a more straightforward and genuine proof. So we know that, note that, so A is less than B, so B is A plus B minus A, and this B minus A is positive. This is what we mean by A is less than B. So similarly, C is less than D, so D is C plus D minus C, and this D minus C is positive. Now hence BD is equal to A plus B minus A C into C plus D minus C. Hence BD is equal to, on expanding this, AC plus A into D minus C plus C into B minus A plus B minus A into D minus C. Or I'll start writing somewhat to the left, because, or I'll write BD is equal to AC plus A into D minus C plus C into B minus A plus B minus A into D minus C. Now note that all these terms are positive. B minus A is positive, D minus C is positive, A is positive, C is positive. Hence BD is AC plus some positive thing. Hence 0 is less than AC is less than BD. So this is another proof which is straightforward. We found that AC is less than BD. Right. So can we multiply inequalities? Yes, we can multiply inequalities. And so to recap, what did we do? We considered what A less than B means. A less than B just means A is to the left of B. We considered what A is greater than 0. A is positive means. A is positive just means A is greater than 0. We then rewrote A less than B in terms of positivity. A less than B is same as saying B minus A is positive. Hence, we are asking to study inequalities, it suffices to study positivity, so to speak. So we are asking what are the basic properties of positivity. We found out that addition, multiplication preserve positivity, and we have trichotomy. Every real is either positive or 0 or such that minus A is positive. These two properties, the addition, multiplication preserving positivity and trichotomy, are considered the basic properties of positivity. Now we are asking some questions about inequalities. What are the operations we can perform on inequalities? Like, can we take chains of inequalities? We found that yes, we can take chains of inequalities. A less than B and B less than C. If A is less than B and B is less than C, then we can conclude A is less than C. Then we asked, can we add a number both sides of an inequality? We concluded yes. So if A is less than B and C is any real, then A plus C is less than B plus C. So we can add any real number both sides of an inequality. Then we ask, can we multiply a positive number both sides of an inequality? So it turns out yes, if A is less than B and C is positive, then AC will be less than BC. Then we asked, can we multiply a negative number both sides of an inequality? So we looked at addition of number both sides of an inequality, and now we are looking at multiplication of a number both sides of an inequality. We asked, can we add a negative, so can we multiply a negative number both sides of an inequality? So if we have A is less than B and C is negative, then AC will become greater than BC. So we can multiply both sides of an inequality by a negative number, but we'll get but the inequality will flip the direction. So A less than B, from A less than B we will get AC greater than BC when C is negative. So after that, we can add numbers both sides of an inequality, we can multiply numbers both sides of an inequality. Then we ask, can we add inequalities? If you have two inequalities, can we add them, so to speak? So if A is less than B and C is less than D, it turns out we can conclude A plus C is less than B plus D. Then we asked, can we multiply inequalities? It turns out if all the terms involved are positive, if 0 less than A less than B and 0 less than C less than D, then we can conclude 0 less than AC less than BD. So A less than B and C less than D implies AC less than BD when all the terms A, B, C, D are all positive. So we can multiply inequalities. So these are some basic some basic properties of inequalities. And right, so that's all for this part. See you in the next part.